Good morning, friends. Today we are starting our next unit. We are starting with Po39. I can determine the number of possible outcomes of an event. So we are going to be working with probability with this unit. So we need to know what probability means. Probability is the likelihood of an event happening. So what is the likelihood that this event will happen? We have a scale of probability. Probability we can measure in percentages. So 0% all the way up to 100%. So if there is no chance of this happening, that would be a 0%. There is 100% chance of this happening. It will happen. It is happening now. That's 100%. In the middle would be the 50%. We've got our 25% in the middle of that and 75% in the middle of that. Down below 50% means it's not likely. Greater than 50% means it's likely going to happen. We don't know for sure if it will, but there's a good chance it's likely to happen. If it's less than 50%, it's probably not going to happen, right? I would say our probability of us getting another snow or cold day this winter, I'm guessing it's not likely, even though I would love for it to be 100%. I'm guessing it's probably not likely. We don't usually get a whole lot of those in 1 year. So we've already gotten one. It's going to be not likely that we'll get another one. But it's not a 0% chance. We still could. Eleanor.
So would this count as a formula so we could put in our help sheet? Or would this count as an example?
That would not be an example. Okay, so determine how many possible outcomes there are for an event. We need some way to figure out everything that could possibly happen. There are 2 ways that we can do this. One way is using the probability tree. One way is using the counting principle. So let's look at that probability tree first. Let's say we flip a coin 3 times. How many possible outcomes are there? So for flipping a coin, definitely not 6. So let's look at this. We have 3 flips, so there's 3 events happening. There's flip 1, flip 2, and flip 3. So for our flip 1, what 2 outcomes could we have? Christina?
Both sides,
Heads
yeah, heads.
or tails? Right, so flip 1, you could get a heads or tails. Then for flip 2, if we got a heads for the first one, how many options are there for this one? Heads or tails again, right? Oops. So we would have heads or tails. And then if we had flipped a tails first, again, we would have heads or tails. So then for flip 3, same thing. If we had had the heads there, we could have heads or tails. If we had had a tails, we could have heads or tails. If we flipped the heads here, we could have heads or tails. And if we flipped heads here, we would have heads or tails. So then we have to look at our outcomes. We could have heads, 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 tails, right? Heads, 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 tails. So then we could have heads, tails, heads. Heads, tails, tails. We could have tails first, then heads, heads. Tails, heads, tails. Tails, tails, heads, and tails, tails, tails. So we're going through all those combinations. So we're looking through and saying, okay, we had the heads, heads, heads. Then we had heads, tails, tails. Heads, heads, tails. Heads, tails, tails. So we're just writing out all the different combinations that we could get. How many different possible outcomes there could be. Robbie, how many possible outcomes are there? Count them up. All of our outcomes.
8.
Yeah, there are 8 possible outcomes. See how that works? So if we're doing that probability tree, we can see what each one of those outcomes could be. On our last math packet, you have 4 different tops, 4 different bottoms. How many possible outfits could they wear? So you could write out each one of those outcomes. Black shirt, blue pants, green shirt, orange pants, whatever the colors were. So you could write out each one of those outcomes in a probability tree. We look, it's the same thing for our next option. We had it in our math packet, we have it in our homework. 3 pairs of pants, 4 shirts. What are some possible pant colors that we could have? Christina? Orange, blue, and yellow pants. What are some possible shirt colors that we could have, Claire?
Pink, green, red, and black.
Okay, so probability tree, I have pants, and I have shirts. Now what are my pant choices I could have? So I could have orange, I could have blue, I could have yellow. Then I have 4 different shirt colors. So if I have orange pants, I could have a pink shirt, orange pants with the green shirt, orange with the red, orange with the black. Blue with the pink, blue with the green, blue with the red, blue with the black. Yellow with the pink, yellow with the green, yellow with the red, yellow with the black. So I could do, can you see okay, Alex? Sorry. I think our tables got moved around yesterday because people are having a hard time over here, people are having, yeah. So if we need to shift our table group so everybody can see, we can always shift. Okay, so let's write out our outcomes. We could have orange and pink, orange and green, orange and red, orange and black. Blue and pink, blue and red, blue and green, blue and black. Yellow and pink, yellow and green, yellow and red, yellow and black. How many different outcomes could we have with those outfits? Eleanor? Well, if we counted up all of our different color combinations, there are 12 possible outfits we could have. The reason we would want to do the probability tree is to when we want to see what each of those outcomes are. When we want to see, okay, how many orange outfits could I have? So I can look there quickly and say, oh, there's 4 of them that have the orange pants. Right? It's quick and easy to see each of those outcomes. There is an easier way to do this. So we're going to look at that counting principle. So this is if we just want to know how many outcomes. Okay, we do the probability tree when we want to see all of the actual outcomes, so we could see how many orange outfits are there. Which ones fall in that? How many have the heads in the first set? Okay, so when we want to see the actual outcomes, we do a probability tree. If we just want to know how many possible outcomes there are, first thing we do is we write how many events. Flip 1, flip 2, and flip 3. You need to know how many events there are. There are 3 flips, so that's 3 events. On this side, you write number of outcomes for each event. So on the top, we have our event labels. Flip 1, flip 2, flip 3. On the side, we have number of outcomes for each event. So if we look at flip 1, how many possible outcomes are there for flipping that coin? Christina? Say it again. 2. How many possible outcomes are there for flipping the second coin? David?
2.
How many possible outcomes are there for flipping the third coin? Camilla? 2. Once you have your table filled out, what do you think we do? Multiply them. 2, oops. I don't know why that's not working. I would put, there we go, 2 times 2 times 2. So when you have your table, you have to really look at how many events are there. And under each event, you put how many possible outcomes for that event. This really does matter because I have kids mess this up all the time. You need to make your table so you make sure you have each event covered. You label them because there will be confusing ones there. You roll a 6-sided dice and then you flip a coin and then you roll another dice. You have to put each event on top to make sure you're multiplying the correct outcomes together. I'm telling you right now, this is one that kids mess up on all the time because they forget to label their events and to look at how many outcomes are in each event. Okay? So you really want to pay attention to what your events are. If we look down at our outfits, event 1 would be what? What should I label it as? David?
Pants.
Pants. What's my event 2? Harper? Shirts. And this is my number of outcomes. How many pants are there? Harper, or Hadley? 3. How many shirts are there, Tessa? 4. I know that some of these we can do in our head. But I'm telling you right now, if you get in the habit of just trying to do the mental math, there will be ones that you will do wrong. It does get more complicated. There will be people that forget events or what the correct number are. I'm asking us to remember to do your table so you don't make those simple mistakes. I'm not telling you to do this to do more work. I'm telling you this because I know what kids make the mistakes on the most. And I want you to learn from other people's past mistakes so we don't make those mistakes. Make your table, label each event, and then under each event you put how many outcomes for that event. And then we remember whatever events we have, we multiply those outcomes together. 3 times 4 gives us our 12 outfits. So let's look down below. A password with 5 letters. Letters may repeat. How many possible passwords can be made? Do you think we should do a probability tree or should we do the counting principle? Why would we do the counting principle? Christina? It is easier and it's just asking for the number of outcomes. If that's all we want to do the counting principle, right? If it's just asking for number of outcomes, counting principle is definitely easier to do. So, how many events do I have here? Why 5? Eleanor? There's 5 letters. Each letter in our password is an event. So we have letter 1, letter 2, letter 3, letter 4, and letter 5. Then we need to put number of outcomes. How many outcomes for letter 1? How many letters are in our alphabet? Michael? 26. Now, letters can repeat. So if I have A for my first letter, and put that back in, I could have A again, because letters can repeat. So how many possible outcomes for letter 2? Robbie?
52.
Letter 2, like let's say I have a bag with all 26 letters in it. So I pick my first letter out, it's an A. I'm going to put that A back into that same bag. Now I have another group to pick from for letter 2. How many are in the bag? How many were in the bag the first time? 26. So how many are in the bag for my second pick? The same 26 letters. Because I can just keep re-picking out of that same bag of letters. So letters can repeat. So if I picked a Z for my second letter, I'm going to put that Z back in the bag. How many outcomes for letter 3? Amala? 26 again. All the letters are back in the bag. How many for letter 4? David?
26.
And how many for letter 5? Somebody tell me.
26.
What do I have to do to figure out all possible outcomes? Christina? I have to multiply them all together. 26 times 26 times 26 times 26 times 26. What does that get me? Harper?
30.
26 times 26 times 26 times 20. That's going to be way bigger than that. Beckett?
11,881,376. Yes, Beckett.
Whew! That is a lot of possible combinations for my password. David?
I would actually do 26 different times.
Yes. Can't normally do that, but yes, you could have done that for this one. How many possible passwords can be made if the letters cannot repeat? So we're going to set our table up the same way as the letters 1, 2, 3, 4, and 5. This is my number of outcomes. But this time, if I reach my hand into that bag of 26 letters and I pull out a D, I put that down for my first letter, I can't put it back in the bag because letters cannot repeat. So if I had 26 for my first letter, how many letters do I have to choose from for my second letter? 25. So let's say this time I choose a B. I can't put it back in the bag. How many letters do I have for my next letter choice? Hadley? 24. How many for my fourth, Amala? And how many for my last one, Christina? 22. What's my next step? Ellen, or Harper? Multiply 26 times 25 times 24 times 23 times 22. This time, how many possible combinations do I have? Graham? 7,893,600. So not being able to repeat those letters makes a difference. So we really have to pay attention to what the directions are, what our problem says. Pay attention. Can we repeat? Can we not repeat? It makes a difference. So let's look at our homework page. Well, I should ask first, any questions? Okay. So, determine the possible number of possible outcomes. Show your work. Make your table. That's showing your work. What is your event 1? What is your event 2? Don't just say event 1, event 2. Say coin flip 1. Say no, letter 1. Say roll the dice 1. Okay, so tell me what your actual events are that are happening. Note some answers may be too large to fit on a standard calculator. If we're using the calculator that we've been using, you'll be fine. Okay, if you were using one of my extra calculators in the back, it's not going to be fine. These big kid calculators, you should be fine with it. So let's look. You flip a coin twice, and you roll a 6-sided die once. How many events is that for my table? There are 3 different events happening. So we have flip 1. We have flip 2, because we flipped it 2 times. Each one of the flips is an event. And then we have roll. We only roll it 1 time, so I can just write roll. So now we have number of outcomes. And remember, we have to show our work. So yes, you have to make your table. Flip 1. How many outcomes are there? Harper.
2.
Flip 2. How many outcomes are there? Tessa. And roll 1. How many outcomes, LJ? 6. Then we multiply them together. Super important that we are labeling each outcome, each event. So we don't, when it says flip a coin twice, we know that that is 2 different events. You have to put them in the table separate like that. So we make sure we're multiplying each event's outcomes together. Eleanor. Oh, you have the answer?
Yeah.
So what is 2 times 2 times 6, Eleanor? So a pizzeria boasts 4 types of crust, 15 toppings, and 5 pizza sizes. How many events do you think that would be? How many events? David? 3. You have the event of the crust. You have the event of the toppings. You have the event of the sizes. Then you put under them how many possible outcomes for the crust. How many possible outcomes for the toppings? How many possible outcomes for the pizza slices? Does that make sense? So each one of these is an event. A locker combination with 3 numbers between 0 and 49. Numbers may repeat. How many events is that? If our locker combination has 3 numbers, how many events would that be? Ooh, how many of us are listening to the teacher instead of working ahead? Natalie.
3.
Yeah, that's 3 separate events. Number 1, number 2, number 3. So make sure you're labeling your events correctly. Make sure you're paying attention. Can something repeat? Are we not replacing it? Not replacing changes our numbers. Think about that bag with all of our letters in it. If I can't put the F that I picked out back in the bag, I'll have a different amount of letters for the next one. Any questions on today's assignment? Feeling good? All right, if you are watching this at home, I hope you are well and I hope to see you soon. Have a wonderful day.